Imagine powering your home with the natural energy of moving water. Hydropower makes this possible, capturing the kinetic energy of water flow and transforming it into clean, renewable electricity. For homeowners with access to a flowing water source, hydropower offers a sustainable and cost-effective way to reduce their reliance on traditional energy sources. By harnessing the power of water, you can generate your own electricity, reduce your carbon footprint, and enjoy long-term energy savings. This comprehensive guide will equip you with the knowledge and tools to embark on your home hydropower journey. Whether you have a small stream running through your property or a significant drop in elevation within your water supply, there's a hydropower solution to suit your needs. This guide will delve into the principles of hydropower, explore different system types, and provide a step-by-step roadmap for installing your own small-scale hydropower system. Get ready to unlock the untapped energy potential flowing right through your backyard. Hydropower operates on a simple yet powerful principle, converting the kinetic energy of moving water into mechanical energy, which is then transformed into electricity. This process begins with water flowing from a higher elevation to a lower elevation, driven by gravity. As water flows downward, its potential energy, stored by virtue of its height, is converted into kinetic energy, the energy of motion. This kinetic energy is harnessed by a turbine, a device with blades that rotate when water flows past them. The rotating turbine is connected to a generator, which uses electromagnetic induction to convert the mechanical energy of the spinning turbine into electrical energy. The generator consists of coils of wire rotating within a magnetic field, and as the turbine spins these coils, an electrical current is produced. This electrical current is then channeled through wires to power your home's appliances and devices, providing a clean and sustainable source of energy. The faster the water flows and the greater the difference in elevation, the more kinetic energy is generated, and consequently, the more electricity can be produced. Choosing the right hydropower system for your home depends on factors such as water flow rate, available head, and your energy needs. Two main types of hydropower systems are suitable for home use: microhydro and picohydro. Microhydro systems typically generate between 5 kilowatts and 100 kilowatts of power, making them suitable for homes with higher energy demands or those located near larger streams or rivers. These systems often utilize reaction turbines such as Francis or Kaplan turbines, which are highly efficient in converting water flow into rotational energy. Picohydro systems, on the other hand, are much smaller, generating less than 5 kilowatts of power, making them ideal for homes with lower energy requirements or those with limited water flow. These systems commonly employ impulse turbines like Pelton or Turgo turbines, which are well suited for situations with high head and low flow rates. Picohydro systems offer a simpler and more affordable option for harnessing hydropower on a smaller scale. Carefully assessing your specific site conditions and energy needs will guide you toward the most appropriate hydropower system for your home. Before diving into the installation process, meticulous planning is crucial for a successful and efficient hydropower system. Begin by carefully assessing your site's hydro potential. Consider the water source, its flow rate, and the available head. Conducting a flow rate measurement over an extended period, especially during the driest months, is essential to determine the system's feasibility and potential power output. Next, determine the ideal location for your turbine and generator. Look for a spot with a significant drop in elevation, ensuring the turbine is submerged below the waterline to maximize efficiency. Factor in the distance between the hydropower system and your home, as longer distances may result in energy losses during transmission. It's essential to consult local regulations and obtain any necessary permits before proceeding with the installation. Consider environmental impacts and explore ways to minimize disturbance to the surrounding ecosystem. Thorough planning and careful site selection lay the foundation for a well-designed and efficient home hydropower system. Section 5. Essential components, the building blocks of your system. A typical home hydropower system comprises several essential components working together to generate electricity. The powerhouse, housing the turbine and generator, serves as the heart of the system. Water is delivered to the turbine through a pipe called a penstock, which is typically made of durable materials like PVC or steel. The penstock's size and length are crucial for maintaining optimal water flow and pressure. The turbine, responsible for converting water flow into rotational energy, comes in various types, each suited for specific flow rates and head conditions. The generator, connected to the turbine via a shaft, converts the mechanical energy of the rotating turbine into electrical energy. A control panel regulates the system's operations, monitoring voltage, frequency, and power output. Additionally, a tail race, a channel or pipe, safely carries the water away from the powerhouse after it has passed through the turbine, preventing any backflow or pressure buildup. Selecting high-quality components designed for your specific flow rate, head and power requirements is paramount for a reliable and efficient hydropower system. Section 6. Step-by-step installation, bringing your hydropower vision to life. Once you have a solid plan in place and have gathered the necessary components, it's time to bring your hydropower system to life. Begin by constructing a sturdy foundation for the powerhouse, ensuring it can withstand the weight of the equipment and any potential water pressure. Next, install the penstock, carefully securing it to prevent leaks and maintain a consistent water flow to the turbine. Position the turbine and generator within the powerhouse, ensuring they are properly aligned and securely mounted. Connect the turbine and generator with a shaft, ensuring smooth and efficient power transmission. Install the control panel and connect the wiring from the generator to your home's electrical system. Finally, construct the tail race to channel water away from the powerhouse. It's highly recommended to seek professional assistance for electrical connections and to ensure all safety codes are met. With careful installation and attention to detail, your home hydropower system will be ready to generate clean, renewable energy. Section 7. Calculating your hydropower potential, formulas and estimations. Estimating the potential power output of your hydropower system involves considering the flow rate of the water source and the available head. The power output can be calculated using the following formula. Power equals efficiency times gravity times head times flow rate times density of water, where P is the power output in watts, ETA is the overall system efficiency, typically between 0.5 and 0.8. G is the acceleration due to gravity, approximately 9.81 meters per second squared. H is the head, the vertical distance the water falls in meters. Q is the flow rate in cubic meters per second, and Rho is the density of water, approximately 1,000 kilograms per cubic meter. For example, if your site has a head of 5 meters and a flow rate of 0.1 cubic meters per second, the estimated power output would be P equals 0.7 times 9.81 times 5 times 0.1 times 1,000, which equals 3,433.5 watts, or approximately 3.4 kilowatts. Keep in mind that this is just an estimation and the actual power output may vary depending on factors such as pipe friction losses, turbine efficiency, and generator losses. Section 8. Cost considerations. Budgeting for your hydropower project. The cost of a home hydropower system can vary significantly depending on factors such as system size, site conditions, component choices, and labor costs. Small-scale pico-hydro systems typically range from $2,000 to $5,000, while larger micro-hydro systems can cost upwards of $10,000 or more. The turbine and generator typically represent the most significant expenses, followed by the penstock, control panel, and installation costs. It's important to factor in additional expenses such as permitting fees, electrical wiring, and any necessary site preparation work. While the initial investment for a hydropower system may seem substantial, it's essential to consider the long-term savings. Once installed, hydropower systems require minimal operating and maintenance costs, and you'll be generating your own electricity, significantly reducing or even eliminating your monthly energy bills. Additionally, government incentives and rebates for renewable energy systems can help offset the upfront costs, making hydropower a financially sound investment. Section 9. Maintenance and safety, keeping your system running smoothly. Proper maintenance is crucial for ensuring the longevity, efficiency, and safety of your home hydropower system. Regularly inspect the penstock for leaks, cracks or blockages and clear any debris from the intake screen to prevent damage to the turbine. Lubricate moving parts such as bearings and seals according to the manufacturer's recommendations. Periodically check the generator's brushes and slip rings for wear and tear and clean them as needed. Monitor the control panel for any error messages or unusual readings and address them promptly. Safety should always be a top priority when working with water and electricity. Install safety features such as shut-off valves, pressure relief valves and electrical grounding systems. Never attempt to work on the system while it is energized, and always disconnect the power supply before performing any maintenance or repairs. It's advisable to have a qualified electrician inspect the system periodically to ensure everything is functioning correctly and safely. By following proper maintenance procedures and prioritizing safety, you can enjoy years of trouble-free operation and clean, renewable energy from your home hydropower system.